As usual, Shbab, the beginning, before we look to the lecture, we have to know exactly what we are going to discuss today, what we are going to cover today. Today, we're going to cover two things, velocity and momentum. So the goal to talk about the velocity, everything related to the velocity, and finally the momentum. I think you know what does it mean, these things. So we're going to talk about the velocity. What is the main difference between the velocity and the speed? This is very important. And we're going to spend most of the lecture will be spent on this part, relative motion. Relative motion. This is very important. We're going to set some rules. And finally, we're going to talk about the moment. So let us start, Shabab. So what is the main difference between the velocity and the speed? I will just give you this simple, trivial example, just to feel the differences in between. Now we have a kind of hurricane, storm, that has this speed, 60 km/h. Should you be worried about that? Let me answer this question for you. I would say, if I would be asked this question, I would say, I don't know actually. You have to tell me in which direction the storm or the hurricane is moving. Is it moving forward, going towards me, or away from me? Because up to now, I just know how fast is it, but in which direction is not clear. So that's the right answer is should be it depends. Why it depends? Because simply we don't know the direction. What we have here is the speed. If we know the direction, we'll be having a general information about this hurricane, and it will be very, very valuable. So we started here now. So the velocity is more general than the speed. We can say in a simple argument that will be very helpful for you. V, velocity, we will give it this symbol. V is two things. It's the speed, S plus the direction. So to have the velocity, you have to know these two things, not one of them. We have to have the speed, how fast is it, the value, the number, and also in which direction the object is moving. That will be the velocity. And look at it, Shabab. Look at this simple argument. It means, if you look carefully, we will get some conclusions. It means that the velocity is very sensitive to the speed and to the direction. What does it mean? It means simply, any one of these two things is going to change. We will not have a constant velocity. We will be having a variable velocity. متغيرة. If S changes, or the direction it changes, or both of them change. If any one of these things happen, the velocity will not be constant. So, do you mean that we could have an object that moves with a constant speed, but its velocity is not constant? The answer is yes. The answer is yes. Look at that, Shabab. Here we have an object moves in this road, up and down, up and down, up and down. So the car, the object in this case, I would say it was moving with a constant speed. The speed is constant. I am telling you that it's constant. But of course the direction, Shabab, what do you think? The direction is constant in this case? What do you think?
No.
Of course not. The direction is changing. So as long as the direction it changes, so the velocity of this object is not constant. The speed could be constant, while the velocity will not be constant, depending on the direction. So it depends on these two things. Keep that in mind. Remember, Shabab, velocity also, one of the things that we need to conclude, that the velocity is a vector quantity. It needs a direction. It should be plus or minus, depending on the motion of the object. If the object is moving to the right, the velocity will take plus. If the object is moving to the left, the velocity will take minus sign. If it moves up, it will be plus, moving down will be minus. Keep that in mind. These are the puzzles that I will provide you with, and then you will use all of these puzzles, these pieces, to solve big problems. So please try to understand these simple things. Okay, Muhammad, yes.
So the sign, it depends on the direction.
Yes, it means the direction of the motion of the object, nothing else. So when we have a شباب, I will just talking about that in a moment. When we say that
Okay.
v equal plus 2 meter per second, this plus mean nothing except, it means nothing except the object is moving to the right or upward. If it is negative, it means that the object is moving to the left or downward. Okay, Muhammad, clear? Is it possible for two objects to have the same speed but different velocities? The answer is just like that. Look at that. Two cars having the same speed. So this value is the speed. They have the same speed. But since that one is negative because it's moving, look at that, Shabab. Muhammad, look at that. It's moving to the left, so it's negative. And that moves to the right, it's positive. So they have different directions, so they will be having different, they have the same speed, but different. I would just like to confirm, Shabab, the idea of the velocity depend on two things, not one. Speed and direction. Type. Shabab, by the way, can anyone tell me now, right now, when can we say that the object is moving with a constant velocity? What are the conditions for saying that this object is moving with a constant velocity? Hassan.
When the object travels in a constant speed
Yes.
and a constant direction.
Yes, constant direction, and it should be straight as well. So the object should be moving in a straight line and in one direction, with a constant speed. If it is the case, I will say in this case, it has a constant speed and also it has a constant velocity. This is the only case to have a constant velocity, one direction and one speed. Good. Just to confirm again, Ishbab, just to confirm, we have this car that moves in a circular track, and it moves with a constant speed, 55 km per hour. But as you can see, the speed is constant, but the direction is not constant. This is the circular motion. So at each position, it has a different direction. Since the direction is not the same, the velocity will not be the same. So we have a constant velocity, we have a constant speed, but we don't have a constant velocity. This is the question of Hassan. How to calculate the velocity? Let us just do some simple example. We have this object that will start off the motion from here, and after 10 seconds it will be reaching this point. So this is xi and this is x final. Look how I'm putting, Shabab, the symbols that will help me to solve the problems on the sketch itself. xi, x final. And we need to find the velocity. But let us find s first. I think s is d over t, distance over time. And it should be in this case 20 over 10, which is 2 meter per second. And I shouldn't in any way say it's minus because I'm talking about distance. Distance is always positive. But how could we get the velocity? Shall I say that the velocity also equal distance over time? Is it right? Ashbab.
Can I answer?
Gibran.
Displacement.
Yes, so the velocity equals the displacement over the time interval. It's delta x over delta t, not d. Shabab, look at that. S d over t, where the velocity should be the displacement over the time. The displacement in this case is x final minus x initial divided by the time interval in between, which is in this case 80 minus 100 over 10. That will end up with minus 2 meter per second. Again, Shabab, look at that. Look at that. The difference between S and V. We have this negative sign. This negative sign gives us more information. So we have more. If we have only the speed, we have less information. We know how fast is it, but in which direction we don't know. But if we have the velocity, we'll be having both the speed and the direction. The negative sign means nothing except the direction. The negative sign, or even if it is positive, the negative or the positive sign in the velocity means the direction of the motion of the object. Now we have come to the main part of the lecture today. and it needs your full concentration, because we will شباب, we will set the rules, we will put some rules for us to help us to solve the problems ourselves. We will do that ourselves. It's about the relative motion, حركة نسبية. So something is moving relative to something else. In physics, we say that every single motion in this universe is relative. What does it mean? It means that we have, first of all, to choose a reference point to be able to describe. I think we have, يا شباب, we have talked about that in the last lecture. What is the importance of the reference point? The point that you are relating your position to. Different reference points will end up with different description of the same motion. What does it mean? Look at that, شباب. I will ask you a simple question right now. I am just sitting now on my desk, inside my room, inside my building. Okay? Just answer, شباب. I would like all of you to think about this question and just answer me. Am I moving right now, or I am standing still? What do you think?
Still stand.
Stand still. So you would say, I think all of you will say that you are standing still. Yes. I am standing still relative to what? What is the reference point that you have chosen to say that you are not moving relative to that? I think you will say, for example, والله relative to the walls, ماشي? Relative to the walls, relative to the outside building, relative to anything outside on this planet that is standing still. Anything standing still on this planet, I will be stationary relative to it. صح كده يا شباب؟ طيب. What if another, look at that شباب, this is the first reference point. When we choose this reference point, for example, the walls of my room, I am now standing still. But what if I change it the reference point? يعني I will choose, أنا حر, I will choose a different reference point. I will choose, for example, the moon to be my reference point. In this case, am I still stand still relative to the moon, or am I moving, شباب? What do you think?
Moving.
Of course, I'm moving with the earth, because the earth relative to the moon, the earth is moving, right, شباب? Circulating, moving round and round, right? And I, of course, am just on top of the earth, so I'm moving with the earth relative to the moon. What I want to say, شباب, what I want to say, I'll give you this example just to think about. When we choose different reference point for the same object, our description to the motion could it change? In the first example, you said that I am standing still relative to the walls, and at the same time, the same person, which is me, is moving relative to the moon. So different reference point mean different description of the motion. So I will take this point to talk about the relative motion. And please concentrate. شباب, I will ask all of you, even if you are not raising your hand. Okay, سعد, صالح, Muhammad, Mamdouh, Jibran, you will be asking about that, okay? So be with me. Concentrate, please. Look at that, شباب. Bismillah. We have a car, A. This car moves in that direction. And we have here an observer. This observer is stand still, stationary, is not moving. This is the reference point. This is our reference point. The observer, the one who is recording the speed. Okay, شباب? The one who is recording the speed, and he is stand still right now. The speed of this car, A, relative to this person, يعني when he recorded the speed of this car, he found it to be 5 meters per second. 5 meters per second relative to what? To this person. This is the first step. I think it's easy. Nothing more than that. We have another car, B, moving in the same direction with 5 meters per second relative to the same person. Not relative to the other car. لا. 5 meters per second is the speed that this person recorded. When he looked at B, he found it moving with 5 meters per second. This is the second step. The third step, what if the reference point has been changed? We have chosen another reference point. هيروح فين؟ we have chosen car B to be the reference point. يعني imagine that one of the passengers inside car B looking back at car A and record the speed of car A. بيسجل السرعة of car A. What do you think يا شباب؟ How much would be the speed of car A relative to B? VAB. Again, VAB means the velocity of car A relative to B. يعني B would be the reference, the one who is recording.
0.
Why Hassan it should be 0? I agree, it should be 0 in this case.
It's the same speed.
They are moving with the same speed يا شباب. The distance. طب let me ask any one of the students who answered with 5 or 10. شباب, what about the distance between them? Is it gonna be changed if they are moving in the same direction? Remember, they are moving in the same direction with the same speed. The distance between them, is it gonna be changed or not? ها ممدوح. ممدوح. طيب يعني anyone يا شباب, is the distance will be changed or not?
No.
Of course not.
No.
Of course not, because they are moving with the same speed. As long as يا شباب the distance is not changing. يعني distance is not changing. يعني as if كما لو as if the velocity of car A relative to B is 0. Car A is not moving relative to B. Relative to B. It's really moving relative to this person, but relative to B, is not moving with, there is no change in the position between them. The distance is always constant as long as they are moving with the same speed. Agree يا شباب? Agree?
Yes, I agree.
I agree.
Okay, so it's obvious now. Top. What? Let us just make it a little bit more complicated. What if we have this is not 5, it's 2? How much is the relative velocity between them? It should be easier now. يا شباب. Should it be 7? Should it be 3? What do you think? طب فواز.
3.
Please يا شباب, please. Do not answer until I ask you, please. Yes, فواز.
I think 3.
Yes, it should be 3. So we have set the rule now, Shmab. So that's the first rule today. If we have two objects moving in the same direction, to the right, to the left, they don't need even to be in the same line. يعني they could be like that. المهم, they are moving in the same direction, so the relative velocity between them will be VA minus VB, difference between them. Okay, شباب? What if we change the situation? What if the two cars or the two objects are moving against each other? Against, there could be two cases. This is called against, and also this is called against, شباب. Okay? Both, and both the same. They will take the same rule. Coming closer or moving away. Hi, شباب. What do you think? VAB. Is it still VA minus VB? Well, we have another situation, another rule. What do you think, يا شباب? محمد حنيف.
I think we have to plus them.
Subtract or add?
Add.
Add, yeah, that's right. It will be VA plus VB. So now we have the rules. شباب, please write these rules down. عندك. Write them down. If they are moving in the same direction, we will subtract. If they are moving opposite to each other, in any one of these two cases, we will add the speeds. And that's logic. Let us solve problems about.
I
This-
have a question.
Yes.
Now we know if the objects move to the same direction, then the relative relative motion will be 0, right?
If they have the same speed.
Yes, because the distance doesn't change.
Yes.
But why we add these the speeds if they move to each other?
والله that's logic يا who is that, Muhammad? طيب.
Yes.
طيب. Let us solve this problem, Muhammad. I will just clarify this with this problem. Muhammad.
Okay.
Imagine yourself now, Muhammad, now is riding on this car. You are riding on that car now, okay? Which is moving. طب لا محمد لا. Let us just put it 0. يعني your car is standstill. how much is the speed of car B relative to you?
80.
80. It should be minus 80 مش مشكلة الوقت يعني لأن to the out مش مشكلة. It's 80. Okay. طيب.
Yes.
Muhammad, what do you think if you are moving with any speed? Let us say it for example 20. Do you think that the speed of car B relative to you will be still 80 or more or less?
No, I think more.
يعني you have to add.
Okay, I get it now. Yes,
You got it now.
Yes.
So you've answered yourself. Okay شباب? This is why we
Okay,
have to
thank
add in this situation. طيب. I think خلاص يا شباب, the question is so trivial now. It's 60 plus 80. We have 140 kilometer per hour. طيب. Now we will change the situation a little bit. شباب, look at that. This situation is a little bit different than the previous situation of the two cars moving toward each other in the same direction or opposite. Can anyone tell me what is the main difference between this problem and the other problems? يا شباب, what is the main difference between this example and the other examples that we have just solved it now? طيب, let us ask Saleh, yes.
Because it's same direction.
Yeah, but we have two cars that were moving in the same direction. I'm not talking about the previous example, the previous two examples. The cases. What is the main issue? What is the main difference? طيب, let us ask Gibran. Because now we have one of the objects is inside the other one. شباب, in the previous examples, not example, we were having two things are separated from each other, right? شباب, do you get what does it mean? شباب,
Yeah.
huh? Two cars, a car and a bicycle, a car and a man outside. But now we have one of the objects is moving inside the other one. This is a totally different situation. يعني you can't say that, for example, يعني this object is moving to the right and this to the right, we have to subtract. لا. We have to have another situation here. And we will get this situation. By logic, you don't need to memorize. Just think with me. ها شباب. This person now is moving to the right. And the train also is moving to the right with 25 meters per second. Both are plus because they are moving to the right. ها شباب. What is his velocity? I'm talking about this passenger. What is the... is it a complete question now? I think it's not a complete question. شو يا شباب? The velocity of this relative to what? Because it's different. يعني for example شباب, relative to the other passengers, we have some passengers here are seated. What is the velocity of this person relative to them?
2.
Of course, it should be just 2 يا شباب. He's just moving beside them with 2 meters per second, right? So the reference point is very important. Relative to the passengers, لو ما seated أو seats يعني chairs, it's 2 meters per second. But what is بقى? I think Abdul Hamid was answering this question. What is the velocity of this person relative to the man outside? This person is stand still and he is looking at this person. يا ترى اما اشوفه the train is moving and there's something is moving inside. ها شباب, shall I add the two speeds or subtract? By logic. Let us ask سعد محمد.
Add 2 speeds.
Yes. So in this case we have to add. This is the logic. Right, Asad? This is the logic. I have to add.
Yes.
Something is moving and there's something inside is moving as well. So this thing inside, the person inside, for me, it will be moving with the two speeds all together. This plus that. Good. Let us make it a little bit more complicated. What if this person is moving backward with 2 meters per second? Hashbab. How much will be the velocity relative to that person again? طيب, let us ask, we have asked Hassan Khudran, Hassan Zuhair, Hassan Abdul Hamid. Have not been asked before.
I think 23.
Yes, it will be 23 because I will see him as if he moves with 23 meters per second. طيب, my question is for Hassan again. Hassan Abdul Hamid. Hassan, 23, يا ترى 23 plus or minus?
I think plus.
Yes. يا شباب, although the speed of the person itself is minus 2 relative to the train itself, but at the end of the day I will see this person هو متمشي بالوجه backward, But at the end of the day, in general, I'll be seeing him moving forward, but with less speed than the train will be moving with 23 meters per second. Is that clear, شباب? Is that clear?
Yes, it is.
Relative velocities need you to think about the problem. Just think about it. Imagine it. Just imagine. And ask yourself, where is the reference point? Then just answer the question right. But we have a question here. Look at that. We will use the relative. Although I will not tell you in the problem, try to find the relative. I will not ask you about that. I will give you a general problem, but you have to conclude that it is related to the relative velocity. هنا شباب. We have a bus that has 80 km per hour in front of a car. Let us just draw it. Drawing will make the problem much easier. Try to make a sketch for every single problem. That makes things easier. Put the information on the sketch, that makes things easier. So let us, for example, say that this is the bus and it moves, مثلا, for example, in that direction. It doesn't matter if it is the opposite. I will tell you why. That's 80 and we have a car here. Who is in front? I'm sorry, this is the bus, 80, and this is the car that will be 100. The distance between them is 5 kilometers. And as you can see, the car is faster than the bus. So of course, after some time, the car will catch the bus. Will be in the same place. يا ترى بقى how much the time it will take for the car to catch the bus. يعني we are asking about the time. Let me answer this question for you. ليه يا شباب؟ يعني the purpose for this example is to give you a way, a strategy, how to have your strategy to solve the problem. I will think in this problem in this way. I have in the problem speeds and I have distance and he's asking about the time. Look at these three variables. Do we have any equation that we have had up till now يعني, that is relating these three things together? The answer is yes. The speed equal the distance over the time. And the question was about the time. How to get the time from this equation? This over that equal this over that. So t equal the distance over the speed. I don't think we have any problem with d. D is 5 kilometers. The problem is with s. Why we have a problem with s? Because we have two s. We have 100 and we have 80. Which one is bad? The problem is which one we have to put here. ها شباب, what do you think? 100 or 80 or whatever يعني.
20.
Why it's 20?
100 minus 80.
Yes. So you have got, Hassan,
We have-
ya Saad, you have got the relative velocity. Although I didn't mention that in the problem. I didn't mention anything about the relative velocity, but you have understand it. You have understood it. We have, here we have to put the relative velocity between the two cars, or the car and the bus. And the relative would be, in this case, just 20. So we have 1/4, and it will be quarter an hour. If you would like to convert it into minutes, it will be 15 minutes. But some of you will say that, but what if we just put the because he didn't mention any direction to the right or to the left. What if we just change the direction? And it will be like that. This is the bus and this is the car and they are moving here. Shall I put here يا شباب؟ يعني هنا المفروض بقى ان relative velocity should be negative يعني should be negative. Relative velocity will be minus or negative 20. Like, you don't need to bother yourself about that because we are looking for t يا شباب. T. So because t is should not be bothered. Do we have any negative time يا شباب? Of course not. The time should be positive. So even if you are putting the direction like that, and of course the relative will be negative in this case, don't bother yourself, just put it the positive value because we are looking for the time and the time should not be in any way be negative. يا شباب, clear? Clear?
Yes, yes, yes.
Good, good. We have another question. I will just leave it for you because it's the same, almost the same. All of these are from the old exams, by the way. Now the last part of the lecture is about the momentum. الزخم. What is the momentum? How can we understand the momentum, شباب? What is exactly that? Oh, we know that if I ask any one of you now, you have the equation, the momentum equal mv. Remember, it's the mass time the velocity, not the speed. That's wrong يا شباب. That's wrong. Momentum is a vector quantity, not a scalar quantity. It's related to the velocity, not the speed. So here, this value here is not the speed, it's the velocity. We have a vector quantity here and vector quantity there. First of all, the momentum is a vector quantity. So it has a direction. يعني it could, على طول you have to translate that into your mind. A vector quantity it should have a direction, it should be plus, it should be minus. How could I decide if it is plus or minus? Look at that شباب. The direction of the momentum vector يعني is the same as the velocity direction. They are the same. If you know the direction of the velocity, يعني if the velocity is plus, without any thinking, that will be plus. If the velocity is minus, that will be minus. شباب, just leave the momentum now. I will just give you some summary from the two lectures, and it's very important. Up till now, in two lectures, we have talked about three vectors. The first was the displacement. The second today is the velocity, and the third is the momentum. All are vector quantity, يعني they need a direction. So they could be plus or minus, depending on what? The direction of the motion of the object. يعني يا شباب, this is very important. يعني if you know any one of these three vectors, you can easily conclude the direction of the motion of the object. We have done that before. يعني if I told you that the displacement is plus 2 meters, what does it mean? It means simply that the distance is 2 meters, the object has traveled 2 meters, and he traveled in the positive direction, which it should be, يعني in this case, to the right or upward. If it is negative, it means the object was moving to the left or downward. يعني a sign that is found in the displacement will help us to know the direction of the motion of the object. The velocity the same. The sign in the velocity also will give us the direction of the motion of the object, and also the sign in the momentum. The sign in the momentum also will tell us the direction of the motion of the object. This is very, very, very important. We will need that to solve the problem. If you don't know that, if you can't understand these points, which is so simple, yeah, you will not be able to solve big problems. The units of the momentum is kilogram meter per second, because it's simply the mass is kilogram, and the velocity is meter per second. It's directly proportional to the mass, يعني the bigger the mass, the bigger the momentum, and also the bigger the velocity, the bigger the momentum. We know that. A moment before, we agreed that the momentum is a vector quantity. يعني it should have a direction. It should be plus or minus, depending on the direction of the motion of the object. For example, we have two balls now, شباب. Ball number 1 and ball number 2. They are moving. As long as they are moving, they should have a velocity and they should have a momentum, because they have masses. So this ball has a momentum P2, and that ball has a momentum P1. This one moves to the right and that one moves to the left. Look at that, شباب. This momentum now, directly, you have to put a negative sign here, because it's to the left. And that one moved to the right, it should have a plus sign. That's it. Type. Can we get the total momentum of the two objects if I ask you to solve and to do so? Yes. The total momentum B total equal the first momentum plus the second momentum plus the third plus, depending on how many objects you are counting. Here we have just two. خلاص, يبقى B total in this example will be B1. Is it plus or minus? In this example, it's a plus, so I will just keep it plus. What about B2, شباب? B2 is negative in this, so I will just put it negative. So the total يا شباب, the total هو صحيح ان التوتال is plus, but we have to change it. This is general. We can change these signs here depending on the example that we are studying. In this example, P2 is negative, so I shall change this sign to be negative here. P1 is positive, I will keep it positive. The last thing, Shabab, is for a stationary object, a non-moving object, of course, the momentum will be 0, no matter how big is it. This building that we are residing in now, this big building that has a very huge mass, has a momentum equal 0 because it's not moving. Now we have a question. We have 80 kilogram person driving 1000 kilogram car. And the car is moving with 20 meter per second due north, yani in the north direction, so the velocity will be plus. What is the momentum of the person? We have some confusion of the students, which should be so simple, yani it's just direct substitution in the law. P of the person equal the mass of the person times the velocity of the person. The mass of the person is 80 times the velocity of the person, which is 20 plus, because it's a plus. That should be 1600, and the unit would be kilogram meter per second. Some of the students would answer this question by adding the mass of the person to the car. Yani يقولوا I shall put here not 80, it will be 1080 kilogram. That's wrong, Ishbal. That's wrong. Because I have asked you about the momentum of the person. The momentum of the person is the mass of the person times the velocity of the person. And if I ask about the momentum of the car, just if I said that just the car, if I should put the mass of the car only. But if I ask you about the total momentum of the person and the car, in this case I have to add these two masses altogether. Is that clear, Shbab? Last thing, should be trivial. Is it possible for the little Volkswagen, this one, to have more momentum than the Mack track? Should be trivial now. Ashbab, is it possible for a small object to have more momentum than a huge object? Hamd.
Me?
Anyone of you?
Actually, I think yes.
Yes.
Yes, because the velocity.
That's right. Just to confirm the idea, Shabab, the momentum is two things. It's the mass and the velocity. The Mack truck could be having a very big mass compared to the Volkswagen, but the Volkswagen can have much higher speed than the Mack truck. So it will be having, at the end of the day, more. Shabab, think about two things. The bullet, we have a bullet, رصاصة Shabab. The bullet is almost any kind of grams, 100 grams or so, but it has a huge amount of speed, right? It's 100 grams. It could be 2000 or حاجة زي كده meter per second. Huge. And we have a big ball that is huge compared to the bullet. It's 2 kilograms, but the ball is 2 meters per second or so. So the momentum should look at that. Is it easy for us to stop the bullet or to stop the ball? Of course. We need not to think about that. Of course, if you would like to stop the bullet, you will be end up with a big hole in your hand. Why? Because it has a huge amount of momentum, right? Because it has the speed. It's small in the mass, but the speed is substituting this. It's a very high speed, so the momentum will be high. Here we have a big mass, but we have a very low speed, so the momentum also will be low.